unknown. Let's look at the first example. The random variable x is normally distributed with unknown mean, mu, and variance 3 squared. We can represent this on a diagram where we have the unknown mean and the top 20% starts at 20. So this represents x normally distributed with unknown mean and the variance 9. We can solve this by coding the data as a standardized normal distribution, which is normally distributed with the mean 0 and variance 1 squared. With the help of the standardized normal distribution, now we know what the mean is and we know what the standard deviation is. And we also know the area under the graph. To calculate this, we are going to use the inverse normal distribution function on our calculator. So if you have a Casio graphical calculator, then you go to option 2, statistics, then press F5 for distribution, then F1 for normal, and then F3 for inverse normal. If you have the Casio ClassWiz calculator, that is FX991EX, press menu, then option 7 for distribution, then option 3 for inverse normal. And we are going to use for the area representing the shaded part on the left hand side of the graph. On the top part we had 20%, therefore the shaded part will be 80%. What we need to type in the calculator is area is equal to 0.8 or 80%, standard deviation is 1, and the mean is 0. Press equal and you will have the z value equals 0.8416. And now we are going to decode this by using the formula z is equal to x minus the mean over the standard deviation. In this formula, the only thing that is unknown is the mean. So let's work it out. The equivalent of the z was a 20 in our original graph. So we are going to use that. 20 minus the mean over the standard deviation 3. We can rearrange this. So the mean is 17.5. In the statistics A level exam, you are required to round it to 3 significant figures, and we are going to leave it as such. In this other question, the sigma is missing. And we are going to use the same methods, but instead of the mean, we will work out the standard deviation. We can start by drawing a diagram with the mean 50. The probability of x being less than 46 is 21.19%. 46 is below the mean, so we are looking at this side of the graph. We can now code the data into a standardized normal distribution with mean 0 and some unknown z. And we want to find out the z value when the area under the graph on the left hand side is 21.19%. The z is normally distributed with mean 0 and standard deviation 1 or variance 1. On our calculators, we repeat the same steps to reach the inverse normal distribution, and the area under the graph is 0.2119, standard deviation 1, and mean 0. If we type this in, we will have the z value, so that is minus 0.7998. We plug it into our formula to have minus 0.7998 is equal to 46 minus 50 over the unknown standard deviation We rearrange this to get the standard deviation 5.00 to 3 significant figures. Point B is asking us to work at the 90th percentile of the width. We will shade 90% below the graph, and we are interested in this x. Now we already know both the mean and the standard deviation, so it's not necessary to standardize it. We've got our x, which is normally distributed with mean 50 and standard deviation 5, variance 25. Using the same steps on our calculator, for the area now we have 0.9 for 90%, sigma is 5, mu is 50. Press equal, and that will give us the x, 56.4 to 3 significant figures. Now we have a more complex question where both the mean and the standard deviation are unknown. We can start by drawing out a diagram with the normal distribution. The first situation is representing values of x that are larger than 35 represent 2.5%. The other situation, the probability that x is less than 15 is 14.69%. Let's code our data to use the standardized normal distribution with mean 0, some unknown value z. The area under the graph is the same for both of them. So the first two graphs, the first row represented x being normally distributed with an unknown mean and unknown variance. The second row represents the standardized normal distribution, where the random variables z are normally distributed with mean 0 and variance 1. On our calculator, we type in area being 1 minus 2.5% to work out the area on the left-hand side. So the area on the left-hand side is 97.5%. Sigma is 1, mu is 0. Press equal, 1.9600 to 4 decimal places. And for the other situation, we just need to change the area 0.1469 instead of 97.5%. And the standard deviation and the mean stay the same. And the second z value is negative 1.0498. Now we're going to use the formula z equals x minus the mean over the standard deviation. 1.96 equals the equivalent of z1 is 35. We don't know the mean and we don't know the standard deviation. For the second situation, we have minus 1.0498 equals, and the equivalent of z2 is 15. That is 15 minus the unknown mean and the unknown standard deviation. We can rearrange this. We can label this equation 1 and equation 2. If we do equation 1 minus equation 2, we can solve this simultaneously, and then the standard deviation is equal to 6.64495 and so on, which then we can replace in one of the equations. So I'm going to use equation 1 to work at the mean, and if you rearrange this, the mean is equal to 21.975 and so on. So the final solution to 3 significant figures is standard deviation 6.64 and the mean is 22.0.